Question number 6. Multiple choice rational functions. Which of the following statement is false? A. A graph of a rational function will have a hole at x equals to a if x minus a is a factor of both numerator and denominator. B. A graph of rational function will have a vertical asymptote at x equals to a if x minus a is a factor of denominator but not of numerator. C. A discontinuity cannot be removed by defining the function at the point of discontinuity. D. A discontinuity will occur at x equals to a if one-sided limits at x equals to a exist but are not equal. Okay, what do you think is a false statement? Have a good look at it. Think over each. Okay, and most of the other statements, 3 of them are right. And they actually give you definition or they explain you many things. The right statements are very explanatory and useful. So go through it and then look into my solution. First one says, a graph of rational function will have a hole at x equals to a if x minus a is a factor of both numerator and denominator. This statement is correct. It is trying to say that, if you have something like x times x minus a over x minus a, then there will be a hole, not a vertical asymptote at x minus a, because they cancel out. Do you see that? So that leads to a hole, right? So this statement is correct. How about the next statement? A graph of rational function will have a vertical asymptote at x equals to a if x minus a is a factor of denominator, right? That is true. If this was not there, correct? If we had a statement like x over x minus a, right? In that case, we have a vertical asymptote. That is correct. At times, these questions are asked in a different way in communication question. Or explain when will you have hole or when will you have vertical asymptote, right? A discontinuity cannot be removed by defining a function at the point of discontinuity. That statement is partially incorrect. How? Let us say we have a discontinuity of a hole here, right? In that case, I can define a function which can fill in the hole. Do you see that? And make the function continuous. Do you see that part? Therefore, this statement is wrong, right? So that is our answer. Last statement. A discontinuity will occur at x equals to a if one-sided limit at x equals to a exists but is not equal. What they're trying to say here is that, think like this. Let's say there is a function, right? A function here and a function here. So one-side limits at 0 are there, but this is, let's say, minus 1 and this is plus 1. They are not same. And you can see there is a discontinuity. So this statement is also correct. I hope you understand the concepts here, right? And that should help you in many other types of questions, especially communication questions. Thank you.